For years, experts said a star like Betelgeuse would save its most violent warning signs for the very end. Then, in late 2019, one of the brightest stars in Earth's sky suddenly began to fade, and not by a tiny amount. By February 2020, Betelgeuse had lost more than 2/3 of its visible brightness. Telescopes on Earth, Hubble in orbit, and instruments watching in ultraviolet all caught the same disturbing pattern. A red supergiant, around 700 light-years away, was starting to do the one thing astronomers always watch for in dying stars. But what it meant was far stranger than a simple countdown. If you have ever looked up at Orion on a cold, clear night, you have seen Betelgeuse even if you did not know its name. It sits on the hunter's shoulder, burning with an orange-red glow that looks almost alive. It is not just another bright point in the sky. Betelgeuse is one of the largest stars visible without a telescope. If it replaced our Sun, its swollen surface would stretch past the orbit of Jupiter. More than 400 million suns could fit inside it. It is only about 10 million years old, incredibly young compared with our Sun. But because it was born so massive, it is already deep into old age. That is the brutal rule of the universe. The biggest stars live the fastest and die the hardest. Astronomers have watched Betelgeuse for centuries because it never behaves like a fixed object. Its brightness rises and falls. Its outer layers expand and contract. Giant cells of hot gas boil up through its surface like something between an ocean storm and a furnace. Betelgeuse has long shown a roughly 400-day cycle, a slow heartbeat written in light. It also seemed to have a longer cycle, around 2,000 to 2,100 days, that kept showing up in the data without a clear explanation. Even before the world heard about the great dimming, researchers knew the star was unstable. They just did not know how unstable. That is why the first signs in 2019 mattered so much. Hubble was not looking at a random flare or a one-day flicker. It was seeing dense, hot material moving out through the star's atmosphere in September, October, and November of that year. The gas was racing outward at around 200,000 miles per hour. In visible light, backyard skywatchers had not yet seen the full drama. But in ultraviolet, the warning was already there. Something on or near the surface of Betelgeuse had broken loose. Then came the part that made astronomers around the world stop and stare. By the end of 2019, the southern region of the star looked dramatically darker. ESO images comparing January 2019 with December 2019 showed the change clearly. This was not a vague impression. Part of the face of Betelgeuse had visibly dimmed. By mid-February 2020, the star had dropped to a brightness level so low that even casual observers could tell something was wrong. The familiar shoulder of Orion looked wounded. The first public reaction was immediate and almost unavoidable. Was this it? Was Betelgeuse about to explode? That question had real weight behind it. Betelgeuse is a red supergiant, and red supergiants do not end quietly. They die in supernova explosions powerful enough to briefly rival entire galaxies. Astronomers had already suspected that massive stars may show violent unrest shortly before death. In 2020, a different red supergiant in another galaxy, later identified as the source of a supernova, called SN 2020 Tel-F, was seen brightening and throwing off gas in the final months before it exploded. That discovery mattered because it showed the warning signs might be real. A dying giant star can grow unstable, belch material into space, and then collapse. So when Betelgeuse dimmed so dramatically, people did not need much imagination to connect the dots. But the truth turned out to be both less immediate and more fascinating. Hubble's ultraviolet spectra, along with data from ground observatories, suggested that Betelgeuse had not started exploding. It had done something astronomers had never directly seen before in a normal star. It had blown off a huge piece of its visible surface. That phrase almost sounds too dramatic to be true, but that is essentially what the data pointed to. Researchers concluded that a gigantic surface mass ejection had hurled hot material away from the star. Our Sun also ejects material, but what Betelgeuse did was on another scale entirely. NASA described it as roughly 400 billion times the mass of a typical solar coronal mass ejection. The chunk that escaped likely weighed several times as much as Earth's moon. As that material moved farther from the star, it cooled, condensed into dust, and formed a dark cloud that blocked part of Betelgeuse's light from our point of view. In other words, Betelgeuse did the one thing astronomers warned about. It started shedding itself in a violent, visible way. That does not mean the star is about to detonate tomorrow. NASA has repeatedly cautioned that Betelgeuse is still likely tens of thousands, and possibly around 100,000 years, away from its final supernova. That is an important reality check, but it does not make the event less extraordinary. For the first time, scientists were not just guessing at how a red supergiant loses mass before death. They were watching it happen in real time, and the star did not simply go back to normal. That is where the story becomes even stranger. After the dust cloud explanation began to settle in, astronomers kept monitoring Betelgeuse. What they found next suggested the outburst had not been a passing surface accident. It had shaken the star more deeply. The 400-day pulsation cycle that observers had tracked for around 2 centuries appeared to be disrupted. Some researchers described the star's interior as bouncing. One comparison from the Hubble team made it sound almost physical. Betelgeuse, they said, seemed to be jiggling like a plate of gelatin. Think about what that means. We are talking about an object so large it would swallow the inner solar system, yet it can still be thrown off rhythm by a single convulsive event. A giant plume, perhaps more than 1 million miles across, may have risen from deep inside the star, combining with its normal pulsation to blast matter outward. Afterward, the outer layers looked closer to normal in some spectra, but the deeper pattern of the star's brightness had changed. It was as if the star had coughed so hard it lost its breath. That alone would make Betelgeuse one of the most important stars in the sky. But then another mystery resurfaced. For decades, astronomers knew Betelgeuse had that longer cycle, about 1,200 days, or roughly 6 years. The usual suspects were all on the table. Maybe giant convection cells, maybe dust, maybe magnetic activity, maybe some weird pulsation nobody fully understood. But as more studies came in, a different idea started to harden. Betelgeuse might not be alone. The suspected companion had a name waiting for it: Sawarha. It would be far smaller and vastly dimmer than Betelgeuse, buried so close to the red supergiant that seeing it directly was like trying to spot a tiny Christmas light in front of a flood lamp. For a long time, the evidence was suggestive, not decisive. Some imaging hinted at it. Some models liked the idea. But proof is a brutal standard in astronomy. A star that bright can fool you. A star that turbulent can mimic motion and structure that are not really there. Then researchers began looking not for the companion itself, but for its trail. Using Hubble and ground-based telescopes, astronomers tracked subtle changes in Betelgeuse's light and the motion of gas in its extended atmosphere over nearly 8 years. What they found looked like a wake. Dense material seemed to be swirling through the outer atmosphere just after the companion would cross in front of Betelgeuse from our point of view. The pattern repeated on the same long cycle. The image the lead researchers used was simple and perfect. It was like a boat moving through water. That wake may help explain why Betelgeuse changes brightness on that longer cycle. A small companion moving through or near the bloated outer atmosphere could disturb gas, push dense material into our line of sight, and shape the appearance of the star in a repeating pattern. It might even help explain why Betelgeuse appears to rotate faster than expected for a swollen old red supergiant, though that part remains debated. Some studies suggest a past merger with another star could account for the strange rotation and unusual chemistry. Others argue that huge convection cells can trick observers into reading false rotation from the data. Betelgeuse keeps refusing to be reduced to one neat answer. And that is exactly why this star matters so much. Astronomers are not watching Betelgeuse because they expect fireworks any second. They are watching because it is one of the only giant stars close enough and large enough for us to study in this level of detail. Most stars are just points of light, even in powerful telescopes. Betelgeuse is different. Its surface can be imaged. Its atmosphere can be tracked. Its outbursts can be seen building over months. It gives scientists a front row seat to a phase of stellar life that is usually hidden by distance, dust, and bad timing. And the timing really is extraordinary. For generations, astronomy had to reconstruct the deaths of massive stars after the fact. A supernova goes off in a distant galaxy, and researchers rush to search old images for the star that used to be there. Maybe they find a red supergiant. Maybe they detect a hint of circumstellar gas. Maybe they build a model and ask what might have happened in the last year, the last month, or the last few days. But with Betelgeuse, and with a few newly observed supernova progenitors, the story is changing. Scientists are beginning to catch the warning signs before the final collapse. That is the turn in this story. The Great Dimming was not just a strange sky event, it was a preview of a new kind of astronomy. One where we stop treating stellar death as a clean before and after and start watching the messy middle. The boiling, the shedding, the instability. The moments when a star does not explode but shows you that it can feel the pressure building. Some researchers believe events like Betelgeuse's giant surface ejection may be more common than we realized. We may simply have lacked the ability to witness them clearly. Red supergiants lose mass all the time. Over spans of thousands to millions of years, they can expel enormous amounts of material into surrounding space. But what stunned astronomers here was not just the loss of material, it was the violence, the scale, and the fact that the event changed the star's behavior afterward. Betelgeuse did not merely leak, it convulsed. That word matters because it changes how you picture a star. Most people imagine stars as stable balls of fire, constant and far away. Even when they think of something dramatic, they imagine a sudden explosion, one single clean event. But stars like Betelgeuse are not stable in any ordinary sense. They are layered engines fighting gravity with fusion, radiation, turbulence, and pressure. Near the end of life, those forces become less balanced. The outer regions puff up, surface gravity weakens, convection grows colossal, pulsations travel through the star, material can be pushed outward more easily, and every now and then, the star may quite literally throw part of itself into space. That is what makes the phrase so unsettling. Betelgeuse is doing the one thing astronomers warned about. It is not exploding yet. It is not sending a deadly blast toward Earth. But it is acting like a star in distress. And distress in a star this large is not a small thing. Imagine the scale for a moment. The plume thought to be involved in the 2019 event may have stretched more than 1 million miles across. The expelled material moved through an atmosphere heated to extreme temperatures, then cooled millions of miles from the star and became dust. That dust blocked light from about a quarter of the visible disk, according to the Hubble interpretation. In visible images from ESO, the southern hemisphere looked scarred. Then the familiar rhythm of the star broke. A 2-century heartbeat vanished, at least temporarily. This was not a decorative twinkle. This was internal upheaval written across interstellar space. There's another reason scientists keep returning to Betelgeuse, and it reaches beyond curiosity. Massive stars are factories for the heavy elements that shape future worlds. They forge carbon, oxygen, and other elements in their cores, then scatter them into space through winds and explosions. The calcium in bones, the iron in blood, the oxygen in water, the silicon in rock, all of it comes from stars that lived, changed, and died long before the sun was born. So when astronomers watch Betelgeuse lose mass, they are not just watching damage. They are watching cosmic recycling begin before the final blast. Part of the future of the galaxy leaks out of this star every time it convulses. Still, the tension remains, because one question always comes back. If this is not the supernova, then how close are we really? The honest answer is that nobody knows in human terms. Astronomers can say Betelgeuse is nearing the end of its life in the broad cosmic sense. They can say it is a red supergiant destined to collapse and explode. They can say its recent behavior teaches us what late-stage instability can look like. But they cannot point to a calendar. They cannot say next year, next century, or next millennium with any confidence. When NASA says the chance of Betelgeuse going supernova anytime soon is pretty small, that is not a dodge. That is the current best judgment from the evidence we have. And that uncertainty is part of the fascination. Because for a star, 100,000 years can count as soon. That is the scale mismatch that makes astronomy feel almost supernatural. Betelgeuse may be calmly winding toward an end that is still unimaginably far off for us, while also displaying physical warning behavior right now. Both statements can be true at the same time. The star can be stable on the level of civilization and unstable on the level of stellar evolution. What happened next only deepened that sense of watchfulness. Studies after the Great Dimming found new patterns in Betelgeuse's variability, including a stronger 200-day signal that may have been triggered by the outburst. Some modelers suggest the ejection and hot gas plume could have kicked the star into a new pulsation mode that might fade away over 5 to 10 years. If that is right, then Betelgeuse is still ringing from a blow it took years ago. The star may quite literally be echoing. That is an eerie thought. Somewhere in Orion, a giant red star is still carrying the aftershock of a self-inflicted wound. Every new observation becomes part of a longer medical chart for an object that is too big for human intuition. And every time the data shifts, researchers have to ask the same question again. Is this just atmospheric chaos? Is it a companion carving through gas? Is it evidence of a past merger? Or are we seeing several layers of truth stacked on top of each other? The big reveal, if there is one, is not that Betelgeuse is about to destroy us. It is that the star has become a live laboratory for the final behavior of massive suns. The great dimming, the giant surface mass ejection, the disrupted pulsations, the suspected hidden companion, the wake in the atmosphere, the unresolved debate over rotation, all of these threads point to the same deeper picture. Dying stars are not simple. Their last chapter may be full of rehearsals, false starts, structural damage, and violent shedding long before the final collapse arrives. That matters because astronomers once had only theories for many of these steps. Now they have evidence. In another red supergiant, researchers watched brightening and gas ejection shortly before a real supernova. In Betelgeuse, they watched a nearby giant launch a huge amount of material into space without immediately dying. Put those together, and the message becomes harder to ignore. Mass loss, instability, and sudden outbursts are not side details. They may be central to how some massive stars approach the end. There is another layer to this that makes the whole event feel even more immediate. Betelgeuse is not only one of the few stars whose surface we can study in detail, it is one of the few stars that ordinary people can monitor with their own eyes while professional observatories collect precision data. During the Great Dimming, the same star that triggered alerts in research circles was hanging over neighborhoods, highways, farms, and city rooftops. You could stand outside, look up at Orion, and watch the same object Hubble was measuring from orbit. That kind of overlap is rare. Usually, the most important changes in the universe happen far beyond human senses. This time, the signal reached both the world's most advanced instruments and anyone willing to look up. That created a strange bridge between everyday life and deep time. A commuter walking home under winter skies, a backyard observer with a notebook, a scientist comparing spectra on a screen late at night. They were all, in some sense, looking at the same warning pattern unfold. And that matters for more than romance. It reminds us that astronomy is not just the study of unreachable things. Sometimes the universe puts a case study in plain sight and leaves us no excuse to ignore it. The measurements themselves are a lesson in how fragile our assumptions can be. In visible light, Betelgeuse looked like it was fading towards some catastrophic threshold. In ultraviolet, Hubble saw heated gas moving outward before the full dimming became obvious. In high-resolution images from the European Southern Observatory, the southern part of the star appeared much darker than before. In spectra, the behavior of elements in the outer atmosphere changed. Each instrument was catching a different layer of the same event. No single observation gave the full answer. Only when the pieces were assembled did the picture sharpen into something coherent, an outburst, expelled material, cooling gas, new dust, and a star whose normal rhythm had been knocked sideways. That is worth dwelling on, because it says something important about how scientists recognize danger in space. They do not wait for one giant dramatic sign. They look for small changes that line up across different methods. A speed change in gas, a dip in brightness, a darkened region in an image, a repeating period that no longer behaves the way it used to. On their own, each clue can mislead. Together, they start to form a pattern that is harder to dismiss. Betelgeuse is a perfect example of that discipline. The star did not hand over a simple confession. It had to be read carefully, almost like a witness who keeps changing the story but never quite lying. And the unknowns are big. One active debate centers on rotation. Betelgeuse appears to rotate faster than many astronomers expected a swollen red supergiant to rotate. That is one reason some researchers explored the idea that it may once have merged with another star. A merger could spin the outer layers up and leave chemical fingerprints behind, including unusual surface abundances. But other scientists have pointed out that giant convection cells on a star like this can imitate the signal of rotation in certain observations. In other words, Betelgeuse may be spinning strangely, or it may simply be so turbulent that its boiling surface is fooling us. Both options are astonishing in their own way. Then there's the question of what the ejected material does next. When a red supergiant throws off gas and dust, that material does not disappear. It drifts outward and becomes part of the environment around the star. If enough of it builds up before a future supernova, it can shape what the final explosion looks like when it arrives. Shock waves can slam into that surrounding material and produce extra light, extra emission, extra complexity. So when astronomers study Betelgeuse's current shedding, they are not only studying a temporary disturbance, they may also be watching the slow construction of the stage on which the final event will one day unfold. That makes the story feel less like a single incident and more like a process already underway. Not a countdown in human years, but a transformation in progress. Betelgeuse is changing from a familiar bright star into a richer scientific portrait of how giants unravel. The more it sheds, pulses, dims, or disturbs its own atmosphere, the more it stops being just a famous point in Orion and becomes a record of stellar stress. You can almost think of the dust, the wake, and the broken pulsation as layers of handwriting across the surface of the same message. For the viewer, the deeper pull is probably not fear alone. It is the shock of seeing that even the night sky has warning behavior. We tend to associate warnings with sirens, storms, earthquakes, or failing machines, things close to the body, things that operate on daily time. A star does not fit that mental category. It seems too far away and too slow to speak in warnings. Betelgeuse breaks that illusion. It shows that the universe also has precursor states, unstable intervals, brief rehearsals before major transitions. They may unfold over months or centuries, but they are still warnings in the language of physics. And maybe that is why this story stays with people. It is not just about one red supergiant. It is about pattern recognition on the largest scale we can comprehend. The same human instinct that notices dark clouds before a storm or tremors before a collapse is being stretched all the way to Orion. We are looking at a star and asking whether its changes mean something larger is coming, even if larger still lies far beyond our own lifetime. That instinct is ancient. The tools are new. The feeling is the same. So the real tension is not whether Betelgeuse explodes this year. The real tension is that we now know a giant star can throw off part of itself, darken visibly, lose its rhythm, and reveal signs of an unseen partner while the world watches. That means the old picture of stars as calm background lights is gone for good. In its place is something more honest and more unsettling. A living sky, full of objects under pressure, carrying histories and futures that sometimes become visible without warning. And if that sounds distant, it is worth bringing the story back down to Earth for a second. Every winter, millions of people see Orion without thinking much about it. They see a pattern, a myth, a season. But one of those stars is not quietly shining. It is changing in ways we can detect in our own lifetime, not in some ancient buried record, not only through a reconstruction after the fact, right now. That alone is enough to trigger a deep and very human reaction. We are used to the night sky feeling fixed. Betelgeuse reminds us it is not. There's also a protective instinct buried in the way these stories spread. When people hear that a star is acting strangely, they want to know if it threatens Earth. In Betelgeuse's case, the answer is reassuring. At roughly 650 to 700 light-years away, even its eventual supernova is not expected to be a direct extinction-level event for our planet. It would be spectacular. It would likely be visible in daylight and cast shadows at night for a time. It would flood detectors with priceless data. But current scientific understanding does not place it close enough to be a civilization-ending blast. The danger here is not immediate physical harm. It is the psychological shock of realizing how dynamic the universe really is. Because once you understand what happened on Betelgeuse, the sky stops looking passive. You begin to see the stars as processes, not decorations. You realize the bright points overhead are not fixed lights pinned to a ceiling. They are engines burning fuel, changing shape, throwing off matter, interacting with companions, and moving toward endings at radically different speeds. Some are newborn, some are stable, some are already dead, their last light still traveling, and some, like Betelgeuse, are old giants dropping hints that the last act will not be neat. That is why professional astronomers sound so alert without sounding panicked. They know the difference between a warning sign and a deadline. Betelgeuse has given them the first, not the second. It has shown them violent mass loss, disrupted rhythms, and evidence of a hidden partner shaping its outer layers. It has forced them to rethink how much surface chaos a red supergiant can endure without immediately collapsing. And it has given them a target that will keep rewarding observation for years to come, especially as the suspected companion reemerges for future viewing opportunities. There's a strange kind of validation in paying attention to a star like this. Not because disaster is certain, but because the universe really does leave clues before major events. Sometimes the clues arrive as pulses in a light curve, sometimes as ultraviolet signatures of gas racing outward, sometimes as dust that darkens an entire stellar hemisphere, sometimes as a wake, almost invisible, trailing through a star's own atmosphere. These are the fingerprints of change, and for once, we are catching them clearly enough to follow the story as it unfolds. The softest and perhaps most unsettling part of this story is that Betelgeuse may still be teaching us something we have not fully recognized yet. The star has already forced revisions. It has already embarrassed simple explanations. It has already turned a famous sky object into an active scientific argument. So even now, after the great dimming, after the surface mass ejection, after the companion wake, there is no final clean answer waiting at the end of the chapter. There is only better resolution, better timing, and better questions. Maybe the star's weird long period really is a companion orbiting through its bloated outer layers. Maybe a past merger helped create the strange chemistry and spin. Maybe the disrupted pulsation will settle back into the old 400-day beat. Maybe it will not. Maybe future observations will catch another outburst before anyone expects it. Maybe they will reveal that these giant stars spend far more of their final existence in visible turmoil than our older models allowed. That is why this star keeps pulling astronomers back. Betelgeuse is not just bright, it is legible. It is close enough, large enough, and unstable enough to let us read changes that would be invisible in most other stars. It is a cosmic warning light. Not because doom is imminent, but because process is visible. We are watching the anatomy of stellar aging, and for once, the patient is close enough to see breathing. So, when people say Betelgeuse is doing the one thing astronomers warned about, the real meaning is deeper than the headline. The warning was never just that one day a giant star would explode. The warning was that before such stars die, they may become erratic. They may shed mass violently. They may dim, pulse, cough, and change their own rhythm. They may reveal hidden structures and hidden companions. They may show us that the final road to a supernova is not a straight line, but a field of convulsions. And right now, one of the most famous stars in the night sky is giving us that view. Not the ending, not yet. But the part just before the ending becomes impossible to ignore. If you step outside on a clear winter night and find Orion, Betelgeuse will still look calm. It will still look like a steady ember on the shoulder of a hunter. Nothing in that orange light tells your eyes that the star may have launched a moon-sized piece of itself into space, or that dust once covered part of its face, or that a hidden companion may be stirring its atmosphere like a boat wake through dark water. Nothing in that light tells you that a 2-century rhythm may have been knocked out of balance by a single violent event. The sky hides its drama well, but the instruments do not. The spectra do not. The images do not. And the more closely we look, the harder it becomes to pretend the universe is quiet. Somewhere out there, Betelgeuse is still recovering, still shifting, still offering clues. It may not explode for an age beyond imagination, or it may surprise future generations long before anyone expects it. Researchers are still trying to determine exactly how all the pieces fit together. That uncertainty is not a weakness in the story. It is the story. Because the most honest thing we can say about a giant star at the edge of change is that we are finally watching it closely enough to see that edge move. And once you have seen that, the question that lingers is not whether the star is dangerous tonight. It is how many other stars have been doing this in silence all along, far away, unnoticed, waiting for us to become careful enough to catch their warning signs before the dark and not after it.